In the last video, we showed you how to detect outliers with ibaInCycle. Now we will use the same module to detect wear. Therefore, we will show you the simulated data. What you can see here is our simulated process signal for wear. As in our last example, we'll again learn the first 5 curves to build a reference curve. The following curves will then be merged with this reference curve. Let's go to ibaPDA and do the setup. First, we will go to the I/O manager, where we already created our iNCycle auto-adapting module named Wear Monitoring. The settings of this module are basically the same as in our last example. Except here, we are now monitoring the range of each band instead of the average, and instead of upper and lower limits, now we are using warning and alarm, or in other words, 2 upper limits. Now we will have a closer look at the monitoring. As a reference for the limits, we chose average, which means that the ranges of all 5 learned curves will be averaged instead of taking the maximum range. We choose advanced limits, which also takes standard deviation into account as a limit in addition to the learned reference curve. Here, we select 2 times the standard deviation additionally to the reference as an alert limit and reference plus 4 times the standard deviation as an alarm limit. In the delta calculation, we set whether the exceeded limits of the bands should be summed up or averaged. Number of band results tells us how many band results are available as signals. These signals will be available as analog signals, which will provide information about the exceeded limits of our bands, in our case 5. Now let's start the acquisition. In blue we have our process signal and in red our cycle signal. We will now wait for the first 5 curves to be learned. In the cycle view we see the current curve, which is now divided into 10 bands. Each of them measures the range between maximum and minimum within its band. In yellow you see the alert limit and in red the alarm limit. Every new calculated range curve will then be updated in the waterfall plot. Now that we already learned the ranges of 5 curves, learning is finished and we merge every new curve with the reference curve. We see now that with increasing wear, our range also increases, and as a conclusion, our absolute delta value also increases. This is how we can detect wear with the ibaInCycle module.